Imagine you're building a product. You ask, what are the chances a user buys? What are the chances they click and purchase? What if they already clicked? How does that change things? These are not random questions, they are questions of probability. And today, we will go beyond basics and understand how probability actually works in real situations. Probability is not just about events, it's about how events interact with each other. Sometimes events overlap, sometimes they depend on each other, and sometimes new information changes everything. Now let's come to the OR probability, that is the addition rule. Imagine 60% of people know Python, 50% know SQL, and 30% know both. Now, what's the probability someone knows Python or SQL? Can we just add 0.5 plus 0.6, that is equal to 1.1? Which will be wrong. Why? Because we counted people who know both twice. So we subtract overlap. The final answer will be 0.8. Now let's come to AND probability, that is multiplication rule. Now imagine you flip a coin twice. What are the chances of getting heads both times? First flip 0.5, second flip 0.5. So we multiply both and we get the result 0.25. Now that's correct. When events are independent, we multiply probabilities. Now here's the game changer, that is conditional probability. Let's say a medical test comes back positive. What's the probability the person actually has the disease? This is not the same as journal probability because now we have new information. If many tests give false positive or disease is rare, then even a positive test does not guarantee the disease. Now let's come to the Bayes theorem. Now we go one level deeper. Sometimes we want to reverse probability. What is probability of test being positive if disease exists? What is probability of disease given a positive test? This is called Bayes thinking. Now let's take an example of airport security screening. At an airport, security scanners detect suspicious bags. Only 1% of bags actually contain prohibited items. Scanner detects prohibited items correctly 95% of the time, but sometimes it gives false alarms. If the scanner alarms, what is the probability the bag actually contains something suspicious? Most people think scanner alarm means danger is almost certain, but not necessarily, because suspicious bags are rare. False alarms also happen. This is exactly what Bayes' theorem helps us understand. Bayes' theorem updates probability using new evidence. Evidence changes probability, but context still matters. Now let us take an example of passing an exam. Probability of passing is 0.72, that is 72%. Probability of failing, so we will calculate it as 1 minus 0.72, that is equal to 0.28, that is 28%. Probability is not about predicting a single event. It's about understanding systems, uncertainty, and making better decisions. Now you have moved from basic probability to thinking like a data scientist. In the next video, we will explore sampling and bias. Why data can mislead you. Thank you.